Hey everyone, and let's start another lecture of pointers in CS2505. So today we are going to look at the pointers and arrays, and I kind of already said that beforehand. I said that it will not make much sense right now, but I hope it will start making sense now because we're going to look into it. Okay, so we're going to look into how pointers and arrays work, and how they are kind of interchangeable most of the time. So yeah, the previous examples involved, like in the previous lecture, some of the examples involved only targets that were declared as local variables, right? For serious development, we must also be able to create variables dynamically as the program executes. So remember the dynamic allocation thing I showed you? Like you can use variables to declare arrays instead of making them static, and most of the time you'll be doing that to save memory and stuff. So now let's take a look at them. Okay, in C, this is accomplished by the standard library function malloc and friends. So malloc allocates a block of uninitialized memory and returns the address. Calloc allocates a block of memory and clears it, returns the address. With clears it means basically it puts 0 in every of them, every memory location. Realloc resizes a previously allocated block of memory, returns the address. Okay, so all of them return a address. So whenever someone returns the address, we know that we are going to use pointers. So let's take a look at them. So at first we are going to use malloc. So in this case, int pointer, we are doing malloc of size 1000. So this is the dimension, and this is the size of every element. So it is basically creating 1000 blocks of integers. So it's basically creating a array like this. Character B malloc 5000. So in this case, it's a character one, right? So size of int basically returns 4, and in some PC it will return 8 based on which bit it is using. It is basically returning how much memory is needed for that specific data type. So integer is usually 32-bit. So if you try size of int, it's going to return 4 byte. So basically 4. So size of always returns how many bytes is needed for that specific data type. So if you write like character size of, it's going to return 1 or 1 byte. So in this case, we are creating 5000, and we don't have to do into size of character because we know that size of character is always going to be 1. So in this case, instead of in a array, we are not supposed to be using variables, but in this case, we are using variable to create an array of double. Okay, so this is the syntax. You have to pretty much memorize how it works. You can always look at Google, but this is the idea. Okay, so it's going to be something like a pointer points to a malloc, and the malloc has a dimension into the size of every single element. Okay, so this is how it works. We have the heap space, which I mentioned in the previous lecture. In the heap space, we have the stack, and then we have stack space. Okay, so these places are if stack needs more memory, it gives memory to there. So if we want to use dynamic allocation, we have the heap. Okay, whenever we are doing dynamic allocation, the OS or compiler basically just takes a memory location from that, and then it gives the user that chunk of memory. Okay, and the address it returns is the address that is over here. Dynamic allocation takes place in a region of memories called the heap. Successful calls to malloc returns a pointer to a block of memory that is now available for your program to use. The block of memory may be larger than you requested, but you will never know that. Okay, so it kind of something the OS takes care of. So most of the time you don't have to worry about it. The only thing you have to worry about is whether there was memory that was allocated or not. So if it returns null, you know that it didn't work. But if it doesn't return null, it returns an address, so you know it was allocated and it is safe to use. So heap space is just a space that is like dedicated to your program. It's not outside the program, so you do not have access to the memory outside of it. But if you kind of play with the addresses, or somehow you have like the addresses, like specific memory address of a program that is running outside, then you can actually play with it. But most of the time, like these days, there is a more security, so your program is usually unable to get into other programs, or like mess with them. So but back then it would kind of intersect and there would be some weird stuff happening, but now it's not the case. But anyway, so heap space is something that is allocated for your program, and whenever you're doing dynamic allocation, it's basically taking address from there, like allocating memory and then taking address there. So another thing to point over here is there are memory locations in the heap that was not allocated, and if you try to access them, you will get some sort of error, like runtime error most of the time, and segmentation fault. Okay, so yeah. Allocating arrays dynamically, once again, all of the codes that I will be covering are given in the GitHub, so you can just like download them and run yourself. And I highly recommend that you do that, because running this kind of gives you a better idea of what is actually happening, instead of just like going through the slides. And honestly, rather than going through the slides, if you just go and look at the codes and run it and understand it better, that's going to be more helpful than the slides themselves. Again, everyone has their own way of learning. Just do whatever works for you. And if you ever get stuck, you can always ask me. So you allocate an array by allocating a suitably sized block of memory, right? So we have n over here. We can give it some value like 10. Then we do this. What it's basically doing is dynamically allocating an array, which would be statically allocated if we did something like this. We can use the array notation over here. Okay, any pointer name can be used with a array syntax, bracket notation, but you'd better make sure that the pointer really is an array. So for example, you have a pointer like this, int a equals like something b. Over here b is equal to like 10. And if you try something like this, it is probably going to give you a seg fault. Okay, so whenever you're using a pointer as an array, like doing malloc and stuff, then you can totally use the array syntax. But if it's just pointing to one stuff or not pointing to anything, you shouldn't be doing that. You will get a runtime error. Dynamic allocation failure. It is always possible that an allocation request will be denied. Like if the heap space is completely full, it will be denied. In that case, malloc and friends will return null. A deadly sin is not to check the return value from malloc to be sure that it is not null. So whenever you're working with dynamic allocation, this is something you should be doing. First you allocate, then you check whether it is null or not. If it is null, then you should do a exit one. Most of the time in smaller programs, it will not be a case, but whenever you are working with a bigger program, you should definitely make these checks, because sometimes it will return null, but you didn't check for it. And then you try to access it, and it will say that that memory location doesn't exist, because like for example, PA was returned null over here. Now PA's value is null, right? And now if you try to do something like this, it will be basically like null, which is completely wrong. This is definitely going to give you a segmentation fault. Without the check of a, subsequent code will probably, sorry, it will be PA. Subsequent code will probably lead to a runtime error unless there was no need for an array. Deallocating in C. One of the most glaring difference between Java and C is how memory deallocation is accomplished. In C, we have static allocation, local or automatic allocation, dynamic allocation. The first two are of no particular interest over here. Everything that your C program allocates dynamically must be eventually be deallocated. The responsibility is yours. The failure to deallocate memory in in a timely but safe manner is one of the most common programming mistakes in many languages, including C. So in Java, you have garbage collector. So no matter how many times you use new, it doesn't matter. At one point, garbage collector is going to come. It will check whether that memory is being used or not. And if it is not being used anymore, it will just like deallocate it. That's something helpful for Java. In C, you have more power over the memory, so you have more responsibility. So you have to make sure that whenever you are done working with something, like with a certain memory location, you have to free it. So the deallocation function is called free, and this is how you do it. So check that it is actually freeing the pointer, because the pointer is pointing to the memory location and you only have the pointer to point to that specific memory location, and you use free to the pointer. Free does not reset the value of the pointer on which it is worked on. It just deallocates it. The value you had over there might still be there, but they will not be accessible normally. Free. It is important to understand just what free does or does not do. First, free can only be applied to a pointer storing the address of a target that was allocated by calling malloc and friends, which is calloc and realloc. Second, free can only be applied to a pointer whose a target that has not already been deallocated. If you try to deallocate a pointer that was already deallocated, like free, it will give you a runtime error. Third, when free is invoked on a pointer, the pointer is not automatically reset to null. It is your duty to point it to null. Remember, in the previous lecture, we said that if a pointer is not pointing to anything, it should be pointing to null. So whenever you are done with free, you should be pointing to null. Fourth, free causes the deallocation of the target of the pointer, not deallocation of the pointer itself. You don't free a pointer, you free its target. Okay, so even though you are putting the name of the pointer inside the free as a parameter, you are not freeing the pointer itself, you are freeing whatever was malloced. And array names are const pointers. So how it works for array or static allocation of array is they are const. They cannot be changed. What it means by that is you can actually move a pointer, but you cannot move a array. That is the biggest difference array and pointers have. Like, let's take a look at this code. So, well, we have been looking at this code since the beginning of the lecture. So first we are doing a dynamic allocation, we are doing a static allocation, okay? So we can totally use this, like running loop, and use the array notation. You can also use the pointer location if you want, and in the GitHub I kind of put the pointer location as well for a better understanding. Give it a try running it and see if it makes sense to you. So for free, A can be freed because it was dynamically allocated, but B cannot be freed. It is an error because B is a static allocation. So if there is a static allocation, make sure that you do not try to free it because it's not going to work. It cannot be done as well because B is const. It should not change the location it is pointing to. Okay, so this is the biggest difference between a pointer and an array. Otherwise, they are more or less the same. They can use the same notation and everything, but well, we will see what other differences are there. Array notation versus pointer notation. So this is how we use array, right? We use like a I or something like that to access a certain index. But pointer, we use this. So how it works is B plus I, and then we dereference it. Whenever we dereference it, it goes to that specific location, grabs the value, and gives us the value, right? So how it works is, so this is B, right? And these are the addresses. Okay, so how it works for B is, if it is an integer type, at a time it is pointing to 4 bytes at the same time, because 4 bytes mean one integer. So sorry, 4 bytes, yes, 4 bytes. So at the beginning, this is something B is pointing to. If we do B plus 1, it is pointing over here. it will move 4 bytes each time you increment it. Okay, so we increment it by 1, so it is pointing to this location, and it will point to this, whatever is being stored over here. If we do b plus 2, we go 8. Okay, because 8 means like 2 into 4. That's how. So whenever you're doing an increment in a pointer, it moves that many bytes, like multiplied by that many bytes. Okay, so if we do like b plus 10, we are moving 40, yes, 40 bytes. Okay, because we have 10 into 4. So that's how it works. Okay, then we are pointing here and we need the value, right? So we dereference it. So if you combine the lecture concept of the previous lecture with this one, it makes more sense. So this is a very important thing to point. Make sure you have a better understanding of it. So how it works is b plus 10 into size of 10. You do not have to worry about it when you are working with a pointer. It just does it, like the compiler does it by itself. You can dictate it, like how many how much it is being, you know, like incremented by using typecasting, which we might be seeing next as well. So arithmetic on pointers. So what's the effect of this? This is an allocation of a, right? We can actually point this by a pointer. So how it works for an array is, whenever we declare an array, like a static allocation, the a is basically pointing to the beginning of a, yeah, a is basically pointing to the beginning of a location. Okay, it is pointing here. But the difference with a static allocation and a dynamic allocation is, or a normal static allocation of an array and a pointer that is pointing to an array, is a cannot move, it cannot go down, it only has to be here at the beginning, and by using the like indexing, you are actually pointing to the next location and stuff. But for p, it can actually point to any of these locations, it can change whenever it wants. So that's another thing. So static allocation of an array is basically a pointer that cannot move, a const. Okay, that is also a very important concept to understand. Anyway, int pointer p pointer equals a. So p is actually pointing to the beginning of it, right? So if we do p plus 100, it's going to go to this location or this location. Okay. If we do p minus 50, it actually goes back by 50. P plus plus. So this is something that is very interesting for pointers. If we do p plus plus, p goes to the next index, and so on. If we do p minus minus, it goes back to the index. This is something you should definitely try running yourself and see how it works. So think of it as I meant, that is not graded. Write an array, fill it up with random values or whatever value you want. Now point it by a pointer. Okay, now try using p plus plus or pointer plus plus, whatever you named it, or p minus minus, and try to print it every time. Not the pointer itself, but dereference it. Okay, dereference it and see what value it is actually printing. If you do that, it will make kind of more sense to you of what is actually happening. Okay, give it a try yourself. I mean, it's not possible for me to show everything, and these are some things you should be running yourself to have a better understanding. Okay, arithmetic on pointers. The effect of adding a value to a pointer depends on the pointer type. When an expression that has integer type is added to or subtracted from a pointer, the result has the type of pointer operand. If the pointer operand points to an element of an array object, the array is large enough, the result points to an element offset from the original element such that the difference of the subscript of the resulting and original array elements equals to the integer expression. These are very formal words. I mean, I already tried to explain it in more informal words. Definitely try to run this yourself, and it will make much more sense to you. In other words, if the expression p points to ith element of an array object, the expressions p plus n equivalent to n plus p, then p minus n, where n has the value of small n, point to respectively the I plus nth and I minus nth element of the array object, provided they exist. Moreover, if the expression p points to the last element of an object, the expression p plus 1 points to the points 1 past the last element of the array object. And if the expression q points 1 past the last element of an object, the expression q minus 1 points to the last element of the array object. Okay, so most of the time, if you point to something after the array object, sometimes it might work, sometimes it might give you runtime error, sometimes it might give you garbage error, and these will kind of make sense to you when you are working with assembly. Okay, but for now, these are something you should be learning from experience or running the codes yourself. If both the pointer operand and result points to an element of the same array object, or one past the last element of the array object, the evaluation shall not produce an overflow. Otherwise, the behavior is undefined. If the result points one past the last element of an array object, it shall not be used as the operand of a unary pointer operator that is evaluated. Basically, it will give you a runtime error most of the time. Okay. So using arithmetic one pointers. So we are going to take a look at the library implementation of strlen. So you have already seen strlen in the string lecture. So this is how it is actually defined in the library. Okay, so we are getting the source as a string or character array. So as you can see, the pointer makes more sense to you, right? The reason is because we are actually sending a character array. Okay, so that's why we saw all the pointer notations in the string, and I hope now it makes more sense. So first we have the length. We are setting it to 0. We are trying the strlen, so we have to count how much length it has. Then we are running a while loop. While source not equals to null, okay, 0, null, whatever. This is how it was defined in the library function. We are doing length plus plus and source plus plus. So basically how it's working is if we send comp org as our parameter, we are going to be going like this. At first, source is pointing to 43, which is C, okay? Then we are doing C, source plus plus over here. By doing that, we are pointing over here, then here, then here, then here, then here, and so on. And when we come here, we see that we have a 0, which breaks the loop, and then we are returning the length. Does that make sense? Try to run it yourself. The code is given to you. Here is a slightly more idiomatic version. So instead of, you know, doing the source plus plus in the while loop, we can actually just use increment, right? So if we do increment operator, it works the same way. And as you can see, if you do that, it's going to increment it. It's going to dereference it first, then increment it. Okay, so this is another way of writing strlen. They are both going to produce the same output. So it's pretty much the same like code, whichever you prefer. So we access the current target of the source first, then we move the source to the next array element. Okay, that kind of works. Like it fulfills the criteria we had. So are these two things same? Give it a try yourself. Try running it yourself and see what differences you can see. And if you don't understand what differences are like they have, ask me. But I highly recommend you to try it by yourself first. Also try this one and see what happens. Using arithmetic on pointers, we are going to take a look at the str copy. So this is how it is implemented in the system library. We have a destination and source, we know that. And again, they are both arrays or character arrays, which we already have accepted by now. So we are going to start at I, which is 0. Then we are going to run a while loop. And then we are going to put whatever is in the source into destination one by one. And if there is a 0, we stop there. Okay, so we stop there after we put the 0, not before that, right? And then every time we are doing a I++. And when we are done, we are returning the destination. We know that strcopy returns a pointer to the array as well. So I hope it made sense. So this is another version of it. It is a very shorter version. Does this code make sense to you? Try to think about it by yourself. I am going to give you 5 seconds, and then I'm going to start explaining. So yeah, I hope it already made sense to you, but either way, let's see what is happening. So how it's going to happen is, first, we are going to be here. We are dereferencing source, which is 43. And then we are putting it dereferenced version of dest. So over here, 43. Then we are incrementing both of them. So they are going to go one step forward. Then we are checking whether whatever we put in the destination is 0 or not. If it is 0, it's going to return. Otherwise, it's not going to return it. And of course, there should be a return statement over here, which is the test. Okay. So yeah. So this is what is basically happening. Then it goes to the next iteration of the loop, puts it here, increments them. They go to the second, third location, and so on. So whenever they get the 0, it puts the 0 over here. Then it does the check, and then it breaks it, and then returns list. Okay, give it a try by yourself and see what happens. Identity versus equality revisited. X equal to y. X and y in some precise sense have the same value. In C, this is equivalent to x equals y. X is identical to y. X and y are actually the same object. In C, it is equivalent to ampersand x equal ampersand y. Side notes, if x and y are pointers, then x equals y if and only if x and y have the same target. In other words, two pointers are equal if and only if their targets are identical. So think about it this way. Whenever we are doing x equals y, they are checking the values, okay? But if they are the same object, in that case, you do something like this. Because in this case, they are checking the address, okay? Because we know that x is going to, like ampersand x is going to give you the memory address that was declared somewhere. And then it's checking whether it is the same one as the ampersand y. So basically, by doing this, you are actually checking whether the objects are same or not. Most of the time, you will not be using it. You will just be using it, but it's something you should know about as a C programmer. Memory leaks. A memory leak occurs when a process allocates memory dynamically, then fails to deallocate the memory before losing the access to it. Okay. So we are allocating memory over here, and we at one point are doing p equals null, or start pointing somewhere else. In that case, we completely lose sight of whatever memory was defined here. Okay. So when that happens, there are some memories allocated that were not deallocated. In that case, if someone else tries to use that memory, it will not be able to. Okay. Memory leaks are common in badly written C++ code. Taken to extremes, they can consume all available memory on the system. Afterwards, you won't be able to dynamically allocate anything, even statically allocate anything. Garbage collected memory management automates the process of deallocation, but can never be more efficient than well-written code that deallocates memory manually. Because garbage collector is kind of random. You do not know when it's going to come up. So for example, you have 4 megabyte. Just let's keep it short, okay? 4 megabyte of RAM allocated for a program, okay? But you need, like, for example, 100 megabyte of RAM space for your specific program. What you can do is you use dynamic allocation, you use 4 megabyte, then you deallocate it, and then use another chunk of 4 megabyte and keep going on. You are reusing the whole thing again and again. In that case, 100 megabyte can be used in 25 iteration, but in a Java, it needs the 100 megabyte of RAM, because you do not know when the garbage collector is going to show up. Maybe it will show up in the second iteration and you get lucky, but then it might come to the 99th iteration, but by that time your program will crash because you do not have enough memory. So that's why C or C++ is still relevant, and it's still important for OS and everything that deals with memories and stuff and memory efficiency and stuff, because this much power is not given in any other programming language. You do not get to free memories by yourself. It is always done with some sort of garbage collector, which is pretty random. So if you want to write efficient code, if you want to use as less memory as possible, that's when C, C++, or assembly come in handy. Okay, so that's why these languages are still relevant. They are still used in like video games and like operating systems and all of this, and they are not going anywhere anytime soon. Okay. Memory leaks. One issue you will encounter in testing the Linux implementation of malloc will be zero memory when it is allocated to your process. That hides error. That hides error rather than fixing them. For better testing, the following include this one. Where's my pen? Okay. If you use this one, then the main adds this call. Okay, this will guarantee that memory that is allocated with malloc or realloc is not automatically written with zeros. Okay, so the main idea is whenever you are using the Linux implementation of malloc, it kind of puts 0 over there to make it to be nice. I already told you that whenever you're using Linux and you're using a variable without initialization, they are kind of put 0 in there instead of using garbage values. So in Linux, in malloc or realloc, you will face the same thing, but you should always make sure that you put 0 by yourself or use calloc. Okay. You can also use valgrind to have better understanding of how the memories are allocated and if you have any memory leaks and stuff like that. And there is a module for valgrind. Take a look at that when you can. So yeah, you'll also be using valgrind in one of the assignments probably. The key to good memory management. The key to good memory management practice can be stated quite easily. In designing your system, keep careful track of exactly who, module or function, has ownership of each dynamically allocated object. Practicing this is not easy, but with careful attention to detail and meticulous recording of design decisions about ownership in comments, it is certainly possible to eliminate memory leaks altogether. This is something you have to learn by yourself with experience, because most of the time we will be writing codes that have memory leaks, and we will be writing dangling pointers, which are called spaghetti code, and it is very common in the industry. But with more experience, you learn better about like how to do memory management and everything else. So this is another code. I have given it in the GitHub. You can try running it. So what we are doing over here is we are setting a maximum length. Then we are doing a calloc with maximum length. We do not know how big our string is going to be. Then we are doing a fgets from a file. Okay. After doing a fgets, we have the string, and it might not use the full memory. Maybe it will just use like 50 or something like that. Then we can do a realloc. Realloc basically changes the size of it. So at the beginning it was 1024, right? By doing this line, this is line over here is basically our string or our whatever we allocated our character. Then we are telling the new size of it. instead of the old one. Our old one was this +1. Now we are doing strlen +1. This +1 is for the final none. Okay. Then we are doing into size of character. It is not necessary because the answer is always 1, but it's up to you. But if it is a size of integer, in that case, of course, you have to do that because it's 4. And sometimes it will be 8 based on the machine. Okay, so what reallocation is doing is, for example, at the beginning, our array looked like this, like hello. Sorry, HELLO, and there is the null. And there is like garbage for the rest of the part. And you're not using them, right? So by using this realloc, what is happening is you are reallocating it to this and you are destroying everything else. You are basically deallocating them. Okay, so you are making a better use of the memory. So later on, if in the program, if someone else needs more memory allocated, they can use this chunk of memory. But if you didn't deallocate it, what's going to happen is it will think that there are some contents over here. It will ignore that and it will go to another chunk of memory. And at one point, you might run out of memory. These days, there is a very little chance of running out of memory, but back then you had to be efficient. And if you look at the older video games like Pokemon, you will see that their ROM file is only like 1 megabyte. And these days, video games are like what, 500, like even 50 gigabyte or 100 gigabyte. Witcher 3 itself is like 117 gigabyte. And you're like, why is it so big? At one point, there were games that were just 1 megabyte. And that was because of efficient programming. These days, most of the programs are not efficiently written. People are abusing the fact that we have way too much memory in disposal. So efficiency is kind of thrown out of the window. Okay. So after doing that reallocation, we can allocate another memory for the copy, and then we can copy it by using str and copy. Okay, so this is another way of making sure that you are just efficiently using memory, you are not abusing it. So yeah, in this lecture, we learned about like pointers and arrays, like how they can be interchangeable, how to increment pointer, how to decrement pointer, how to do pointer arithmetic, and how to do dynamic allocation, how to do deallocation, and all of those stuff. These are stuff that are very important to BSc programmer. And if you don't understand this, please do not add in your CV that you know C, because most people will like expect you to be able to do that. And if you add it and you don't understand it, you will have a hard time, like really hard. So yeah, I hope these concepts made sense to you. So if you didn't understand any of this, just let me know. I'll try to explain it much in a clear way if possible. And yeah, I'll see you in the next video.